In this episode of Real Chemistry, we're going to talk about counting molecules using molar mass. And so here we're trying to answer a question like, say we have 17.5 grams of water. How many molecules are there in that amount of water? So you got this cup of water in front of you and you want to know how many individual little H2O molecules are floating around in it. And in this video, we're going to build up the tools necessary to be able to do that sort of calculation. This is actually very similar to my previous video, counting atoms with molar mass and Avogadro's number. So you may want to watch that first. It'll give you a better idea of what we're doing here. So we're going to build up the tools to answer our question in two steps. First, we're going to talk about going between moles and molecules, and we do that using Avogadro's number. Then we're going to talk about going between moles and mass, and we do that using molar mass. And here's the key difference between the atoms video and doing the same process with the molecules, is that now our molar mass is the molar mass of our molecule, and we have to calculate that in our problem. Then we're going to combine those two steps to be able to go all the way from mass to a number of molecules. So first, going between moles and molecules. Our question here says that a teaspoon of salt contains 0.2 moles of sodium chloride, NaCl. How many molecules of NaCl is this? And so what we're going to do here is we're going to do this as a conversion problem, and we're going to use the fact that we know that 1 mole of anything is equal to 6.02 times 10 to the 23rd molecules. And so we can use that equality to write a conversion factor to go between moles and molecules. So we know that we're starting in this case with moles, and that eventually we want to get to molecules. And so we're going to need to write a conversion factor that gets rid of moles and gives us molecules. And that means that when we write our conversion factor, we want moles to go on the bottom, and we want molecules to go up top. And when I fill that in, I just fill that in with my equality. And since 6.02 times 10 to the 23rd is the number of molecules in a mole, I'm going to put 6.02 times 10 to the 23rd up top, which is Avogadro's number. Notice now, my moles are going to cancel, and when I multiply that through in my calculator, I'm going to get out 1.2 times 10 to the 22nd molecules. So that's pretty straightforward. And that looks identical, really, to doing that same problem with atoms. Going between moles and molecules or moles and atoms looks the same. We just use Avogadro's number as a conversion factor to do that transformation. Okay, now let's go ahead and go between mass and moles. So now we have basically the same problem. We have a teaspoon of sodium chloride, and it has a mass of 11 grams. And we want to know how many moles are in that teaspoon. And here, the thing we're going to do is we're going to use molar mass as our conversion factor between moles and mass. And so I've summarized the conversion factors that you'll see in this video down here on the bottom right. And you see that you can go between moles and numbers using Avogadro's numbers, and you can go between moles and mass using molar's mass. So the first thing we're going to do is we're just going to calculate the molar mass of sodium chloride. And so to do that, we go on the periodic table, and first we look at the molar mass below sodium, and that turns out to be 22.99. And then we go and we look at the molar mass of chlorine, and that turns out to be 35.45. And we just add those together. There's just one sodium and one chlorine in that molecule, and when we add them together, we'll get that the molar mass of the whole molecule is 58.44 grams per mole. And that per mole part is very important. This is saying that if I have 58.44 grams of sodium chloride, I have 1 mole of sodium chloride. And that's what allows it to be a conversion factor. And so now we want to go between mass and moles. So we're starting out here with grams. We have 11 grams. And we want to eventually get over to moles. And so our conversion factor is going to need to have our grams on the bottom, our mass on the bottom, so that it cancels out. And we're going to need to have mole on the top. And so we know that in 1 mole of sodium chloride, we have 58.44 grams. So 58.44 grams is 1 mole of sodium chloride. And when we use this in our conversion factor, basically we're going to be dividing 11 grams by 58.44. And if we do that, we'll get 0.19 moles of sodium chloride. So that's going between mass and moles. And that process, again, looks very similar to doing the same thing with atoms. The main difference is now we need to calculate the molar mass of our molecule, and that's really the first step in any of these problems. Let's take one more look at going between mass and moles. In this case, we're given a mass of CH4, which turns out to be methane, natural gas. And it's in kilograms. So it says how many moles of CH4 are in 0.025 kilograms of CH4. And one thing to highlight here is that since our molar mass that we get from the periodic table is in grams, we're always going to need to use grams as our mass when we start. So sometimes there's a conversion problem you have to do first. Sometimes you have to take kilograms to grams, say, before you can begin your problem. So first let's calculate the molar mass of CH4, and then we'll convert kilograms to grams so that we can use that molar mass to eventually calculate moles. All right, so calculating the molar mass of CH4, we just look up the molar mass of carbon on the periodic table, which is 12.01. That's for carbon. And then we're going to add that to 4 times our molar mass of hydrogen, which is 1.01. So this is for hydrogen, and we have 4 of those. And when we add those together, we'll get out a molar mass of 16.05 grams per mole. Now, here's where really it becomes very clear that you can only use this conversion factor with grams, right? Because grams is what's up top here. So if you just try to go ahead and do this problem with that conversion factor and with your mass of methane in kilograms, your units won't cancel out because one's in kilograms and one's in grams. And so that's why we're going to go ahead and take our mass of methane from kilograms to grams. And that conversion, we always just multiply by 1,000. So if there's 0.025 kilograms, then we just multiply it by 1,000 grams over 1 kilogram. That's basically just our conversion factor. And that gives us our grams out. And so that's going to turn out to be 25 grams of CH4. So we have 25 grams of methane. And we're going to want to use that now to calculate how many moles of methane we have. So we did 2 things there before we even began our problem. We calculated the molar mass of methane, and we converted our mass of methane from kilograms to grams, because we can only use molar mass if our mass is in grams. All right, and now we're going from our 25 grams to our moles, and we're going to use our molar mass to do that. And we want grams to be on the bottom so it cancels out. And we want our mole to be up top. And 1 mole of methane is equal to 16.05 grams. And when we multiply that through, we're going to get out that we have 16 moles of methane. I'm sorry, 1.6 moles of methane. So we have 1.6 moles of methane, and their grams cancel out. So to do this problem, right, first we calculated the molar mass of our methane. That's right here. Then we realized, okay, since our mass of methane is in kilograms, we need to go ahead and take that to grams, and that's what we did there. And then we just plugged it into our conversion factor. Okay, so now we've learned how to go between moles and a number of molecules. We use Avogadro's number. We've also learned how you go between mass and moles. We use molar mass. And now we're going to come back to that question we originally asked, how many molecules are in 17.5 grams of water? And so again, we're going to need the molar mass of water. And so we'll just go ahead and calculate that right away. And water, remember, is H2O. And so what we're going to do is we're going to have 2 times the molar mass of hydrogen plus 16.00 for our molar mass of our oxygen. And when we add those together, we're going to get out 18.02 grams per mole for our molar mass of water. So that tells us how many moles we have in a given mass of water. And then we want to actually go all the way from mass to molecules. So this is going to be a 2-step conversion. So these start to look a lot like the more advanced conversion problems we did previously, where you have multiple steps. All right, so we want to go first from grams to moles, and then we're going to go from moles to molecules. And so we have 17.5 grams, and we know that if we want to go to moles, we use molar mass. And so our grams are going to go on the bottom to cancel out our grams that we started with. And that is going to get rid of our grams. You might have asked yourself, how do I know that I want to apply that conversion factor first? How do I know I want to use the molar mass first? Well, there's two ways to think about that. One is, well, I've been given grams, right? And so that means I need to use a conversion factor that has grams in it. And Avogadro's number doesn't have grams anywhere in it, but molar mass does. So that's one way to know. The other is actually if you use the conversion factors in either order, you'll still get the right answer. This is just maybe the more intuitive or clear way to do it. So that's going to leave us with moles. And now we want to go from moles to molecules. And that's where we're going to use Avogadro's number. And remember that Avogadro's number says that in 1 mole, we have 6.02 times 10 to the 23rd molecules. And notice that I put the mole on the bottom. And the reason I did that is to cancel out with our mole that we got in that first conversion factor. And now we're just going to be left with molecules, which is the units here on that 6.02 times 10 to the 23rd. And so when we multiply that through, we're going to get 5.85 times 10 to the 23rd molecules of H2O. There we have it. So that's how many molecules are in 17.5 grams of water. And that's how we can do that. We combine molar mass with Avogadro's number, and we can go between mass and molecules. We could also go the other direction by applying the conversion factors flipped. Thanks for watching this episode of Real Chemistry. Please ask any questions below, and please visit my channel to see other chemistry videos.